we have learned about y-intercepts. Many graphs also have an x-intercept. So we're going to look at these images to see what an x-intercept is. So we learned previously that a y-intercept is where a graph would cross the y-axis, which is the vertical axis right here. And an x-intercept is similar. It is just where a graph would cross the x-axis. And you can see this curved line has two x-intercepts and one y-intercept. And this line right here has a y-intercept and an x-intercept with an example of what the coordinates would be. This point right here is 0, 6. The x-intercept is -4, 0. So in these graphs, we have two graphs here. You are going to circle the y-intercepts in red and the x-intercepts in green. As you can see here, we have y-intercept drawn here or circled here, y-intercept circled here, both in red, and then the x-intercept, you have one on this line and you have two on this U-shaped graph or parabola. Write the coordinate pair, the xy, of the y-intercept in the graph. What do you notice about the x value in the y-intercept? So write the ordered pair for the circled, you can see in red here, the y-intercept, and then maybe in a sticky or you can type in a text box, what do you notice about the x value in the y-intercept? You can see that the y-intercept coordinate pair is 0, 3 for this one right here, up 3. And for this curve, it is here at 0, -3, written right here. And what do we notice in both of these ordered pairs is that the x value is 0. So y-intercepts always have an x value of 0 because they're on the y-axis where x equals 0. Now write the coordinate pair of the x-intercepts in the graph, and there's some blanks for you to type into those text boxes. What do you notice about the y value in the x-intercept? You can see here that the x-intercept is 4, 0. It's to the right 4. It doesn't go up or down, or it wouldn't be on the x-axis. So that y value is 0. And then there are two x-intercepts here. This one is the one that's at -4, 0. This one right here is at 2, 0. And if you look at these ordered pairs, hopefully you notice that the y values are always 0. The y value in the x-intercept is always 0 because the x-intercept is on the x-axis where y is always 0. The reason that we are talking about the x and y intercepts is because when we look at these quadratic graphs, as we're starting our quadratic lesson, they give us interesting information about the scenarios. So for each of these problems, you'll be given a graph to help you solve. When you use the key features of the graph to find information about the scenario, identify the key features now. The reason we're learning about the x and y intercepts is because they usually give us interesting information about graphs. And we're talking about quadratic functions in this lesson. Graphs, equations, and tables all tell stories, and we're going to look at some graphs today that tell stories with the key information that have to do with the x and y intercepts. So this particular example is of a snowboarding half pipe. It's modeled here. This is the origin 0, 0, so we're only looking at the fourth quadrant. And as you go down the half pipe, you get to the lowest point right here, and that is the y coordinate of the vertex, and it tells us the depth, which in this case is -7, so it's 7 meters deep for the half pipe. And then as you continue on the half pipe, you come up on the other side and you get to an x-intercept, and that tells us how wide the half pipe is. So in this case, it goes from 0 to 22, so the width of the half pipe is 22 meters. We are going to do one example together, and then there'll be 3 problems for you to do on your own or in a group. We're going to be looking at these key features of the graph to find out information about each scenario. So in this scenario, we have a grasshopper's jump, which is modeled here. And so this time we are looking at the first quadrant, and we have a very interesting scale. We're looking at time, and we're looking at height. That is the jump. So how long is the grasshopper in the air? And then this tells us how high the grasshopper goes. And to answer these questions, we have some choices here in the side panel. And to answer them, we're going to drag the choice over. How long was the grasshopper jumping? So what was the length of the time of the entire jump? So one single hop ends here. So the length of time is 0.250 or 2500ths or 250 thousandths of a second. And that is right here. So we're going to find that choice in this side panel. And I see that choice right here. So I'm going to get the little crosshairs. I'm going to drag this over and overlay it right here. And I know that this is correct because it is orange, and that was the color of this right here. So this is a self-checking. You know you're in the right spot when your color matched up. What is the key feature that helped you determine this? So what part of the graph was this point right here? If you look over here, these are the key features on the left panel. And this is the x-axis here. So this is an x-intercept. So I'm going to look here for an x-intercept. It's right here on top. Get my little cross and drag that over to this place. And is that yellow? It is, so we know we did that one correctly. When did the grasshopper reach the greatest height? So the greatest height would be right here. What is that point called in a parabola or a curve? We've called it a turning point. It is also called the vertex. And when we're looking at the greatest height, this is the time at which we got to that height. And if I go over this way, this is the actual height. And you can see that the y-axis is labeled with height in centimeters. So 20 centimeters is the greatest height. I can look over here for 20 centimeters and drag that over. Hopefully it is green underneath. It is not. What did I do wrong? The question is asking, when did the grasshopper reach its greatest height? So this is the greatest height. When it happens is right down here because the x-axis represents time. And so it happens at 125 thousandths of a second. So I can find that over here and drag that. Hopefully it is green underneath. We got that correct. What key feature helped you determine this? Well, this is an x-coordinate of the highest point, which is the vertex. That turning point is the vertex. So the x-coordinate right here, if I drag that over, you can see they were both blue. How high could this grasshopper jump? So again, we're going to be looking at the vertex. We don't want to know when, we want to know how high. So its height is over here on the y-axis at 20 meters. How high could this grasshopper jump? That's going to be 20 meters. I can drag that right here. Hopefully it's a light purple. It is, so that is correct. And then what key feature helped determine this? This is the y-coordinate of the vertex. So let's look for this right here. It says the y-coordinate of the vertex. Find my little cross and then drag that over. Hopefully it is a pinkish purple, and it is. So these are the answers to these questions, these key points, and you're going to do this for the next 3 examples. So this graph is based on the quadratic scenario of a duck's dive. And so a duck dives down into the water and then comes back up. Its path is a parabola. And hopefully you've answered these questions right here. Here are the answers. The duck dives 8 meters deep. You can see that this is again in the fourth quadrant. X's are representing time in seconds, and the Y values are the depth of the water in meters, and the duck gets as deep as 8 meters here. And that is the Y coordinate of the vertex. When did the duck reach a depth of 6 meters? So you have to look for when did they get 6 meters deep. It happens 2 times. It happens at 1 second, and it happens at 3 seconds. And that was just another point, actually 2 points on the graph. That's what got dragged over here. How long was the duck underwater? Well, 1, 2, 3, 4 seconds. See, it emerges at the surface of the water again in 4 seconds. And what key feature helped us determine this was the x-intercept, this x-intercept over here. So this x-intercept at 0, 0 was when the duck dove into the water, and this one here at 4, 0 is when the duck emerges from the water again. You can see here, this is an equation that represents the duck, and we're going to be talking more about equations in tables. We may refer back to this. But what do you notice or wonder about that equation? This next scenario is a ball thrown into the air with its pathway sketched below. So it doesn't start at 0, 0, it's starting 1 meter up. Maybe that's the height of the person throwing the ball. And so the ball follows this path. It hits a high point here at 10 meters. So after the ball goes 10 meters, it is at a height of 6 meters. And then it starts falling back down and hits the ground at 21 meters right here. And here you see our answer. So how far was the ball thrown? It landed over here. That's 21 meters. This corresponds, what key feature helped determine this? That would correspond with the x-intercept, one of the 2 x-intercepts, this one right here. The other x-intercept we don't see. It would be here where it's negative. And you know, that part of the graph, if you're just graphing an equation, does exist, but for our scenario, it doesn't make sense. So we're not showing it. What is the maximum height for the ball? The maximum height would be right here, and as high as it gets was 6 meters, and that is the y coordinate of the vertex for the height, and we can see that that's labeled on our y-axis. And then from what height was the ball thrown? So the ball is thrown right here. That is 1 meter, and the key feature that helps us determine that is it is the y-intercept. So when the ball starts off at 0 meters, it is starting at a height of 1 meter. And then you can see this is the equation. And again, I'll ask you, what do you notice or wonder about that equation? This was a very unusual graph compared to the other ones, a little bit similar to the one before in the sense that it doesn't start at 0, 0. This is a diver who's doing a cliff jump and starts at a cliff that is at 400 feet high. So that's our y-intercept over here. At 0 seconds, it is at 400 feet. And this person dives down, and so there's a little arc as they jump up and reaches a maximum height right here. So at 1 second, this person reaches 420 feet, and then the path continues down to the water, and they hit the water at 6 seconds. So looking at the answers here, when did the diver hit the water? When happens at 6 seconds? And what key feature helped us determine that? This is our horizontal axis, this is our x-axis, so it's the x-intercept. From what height did the diver jump? The diver jumps right here at 400 feet. And the key feature that helps us is our vertical axis, which is our y-axis. And so that's our y-intercept. When was the diver at a height of 380 feet? So we have to find 380 feet here, which is right here. And if we follow that over, when does that happen? You can scroll down here. That happened at 2.5 seconds, which is what we have right here. What key feature helped us determine that? It was just another point on the graph. And here is the equation for this function. What do you notice? What do you wonder about that equation? Maybe what information is in there?